Energy codes play a vital role in many areas that are important to our local economies, the well-being of our communities, and the conservation of valuable resources. Buildings utilize 40% of energy in the United States. Energy codes are designed to help us save energy and keep those savings in our local economies. They also improve the comfort and durability of our buildings and the health and safety of the building's occupants. In addition, the federal government has mandated that Alabama reach 90% compliance with target energy codes by 2017 as part of the American Recovery and Reinvestment Act. The target energy code for commercial buildings is ASHRAE 90.1 2007. In this video, we will educate you on how to inspect commercial buildings for energy code compliance using the compliance reports from the CommCheck software developed by the Department of Energy's Building Energy Codes program. We will walk you through the reports showing you how to use them to verify the building's compliance with the Commercial Energy Code ASHRAE 90.1 2007. Thank you for helping to ensure that Alabama's buildings comply with the most up-to-date energy codes.
The 90.1 Commercial Energy Code, along with IECC Chapter 5 Energy Code, focuses on energy reduction for non-process loads in these four major areas: envelope, interior lighting, exterior lighting, and mechanical. 90.1 Commercial Energy Code compliance can be demonstrated in several ways: prescriptive, simple trade-off, or simulated performance. The prescriptive path explicitly spells out the requirements to comply with the 90.1 Commercial Energy Code. You meet each prescriptive value listed as it applies to your building. For example, in Climate Zone 3, the prescriptive R value for roofs in commercial buildings is R38 for ceilings with attic spaces, but only R20 for continuous insulation above the roof deck. Utilizing a tool such as CommCheck, you can show compliance with the code and make simple trade-offs. For example, you could incorporate less insulation to the roof than is required prescriptively and make up for it through the use of better performing glazing. Simulated performance typically requires an energy modeler to be involved. This approach looks at the entire building as fair game: light fixtures, insulation levels, mechanical efficiencies, etc. Simulated performance also could be referred to as a complex trade-off. For example, since the prescriptive code allows only up to 40% glass, you could trade up the efficiency of the mechanical systems to compensate for a higher percentage of glazing. There are certain areas in the code that are mandatory, such as air sealing the building envelope, which would not be eligible to be traded out using any of the three compliance paths. CommCheck is typically used for the simple trade-off approach, but can also be used to demonstrate compliance prescriptively. Since most buildings will use either the prescriptive or simple trade-off approach, it is considered a common practice to require projects to submit CommCheck compliance certificates for envelope, interior lighting, exterior lighting, and mechanical as part of the permitting process. This will provide the code official with project and climate zone-specific checklists and an efficient means to quickly determine compliance. So let's start by reviewing the individual CommCheck compliance certificates and discuss how to use each of them during plan review and field inspections. These compliance certificates can be printed once all the information pertaining to the project has been entered into the CommCheck software. Section 1 of each CommCheck compliance certificate will have the following information: title of the compliance certificate, the energy code version, and the project information or Section 1, which includes project type, project title, construction site, owner-agent name, and designer-contractor name. Now let's look at the envelope compliance certificate in more detail. Section 2 covers general information pertinent to the building envelope. This includes the building location, the climate zone, the building type, the vertical glazing to wall area percentage, the building type, and square footage. Next is Section 3, the requirements checklist. The very first part of this section states whether the envelope passes or fails. Of course, if the envelope fails, a permit should not be issued, nor should the certificate of occupancy. The next part is the climate-specific requirements. The permit applicant uses CommCheck to fill in the specific data about the project's envelope components, areas, and insulation values. This information should be verified both during the plan review and the field inspection. Finally, this section has all the potential mandatory requirements for insulation, fenestration and doors, and air leakage and component certification. Each item has a checkbox which should be checked, indicating that the item is present or marked not applicable for the project. The last section is Section 4, the compliance statement, which states the proposed envelope design represented in this document is consistent with the building plans, specifications, and other calculations submitted with this permit application. The proposed envelope system has been designed to meet the 90.1/2007 standard requirements in ComCheck and to comply with the mandatory requirements in the requirements checklist. This statement should be signed and dated by an appropriate member of the design and construction team. Now that you're familiar with the basics of the Envelope ComCheck Compliance Certificate, let's walk through an example looking at Section 3, the Requirements Checklist. Once compliance has been established in the plan review stage, it's only a matter of confirming in the field that what was drawn and submitted is actually what is being constructed. The first item to look at is whether or not the envelope passes. It does. The design is 1% better than code. Also make sure they're using the correct code and version, either ASHRAE 90.1/2007 or IECC 2009, and that they have the accurate climate zone. From the compliance certificate, we can see that the roof insulation is supposed to be R20 continuous and the wall insulation is supposed to be either R19 BAT or R10 continuous for the steel-framed walls and R10 for the CMU walls. Let's find these on the plans to confirm. The plans confirm what is in the envelope compliance certificate. Once you're in the field, you just need to verify that the insulation was installed as shown in the plans. How about the fenestration? Do the plans validate the U factor and solar heat gain coefficient that is printed on the compliance certificate? They do, yes. So how about the field inspection? While this can be a little bit tricky, if the windows are factory built, then they normally have a label listing the U factor and solar heat gain coefficient values. Easy to verify. But our windows are field fabricated, as many are on commercial projects, so the contractor needs to provide a certificate from the storefront manufacturer that lists the U factor and solar heat gain coefficient values. The contractor on this project has provided the certificate and the windows comply. Let's skip down to one of the mandatory requirements. Under air leakage and component certification, Item 10 states that all joints and penetrations are caulked, gasketed, weather stripped, or otherwise sealed. This item is hard to verify in plan review, so a careful inspection must be done in the field. The next compliance certificate is Interior Lighting and Power. Section 2 shows the interior lighting and power calculation for the baseline allowed wattage. The allowed wattage represents the lighting and power budget which the installed lighting design must not exceed, even if exemptions or allowances seem appropriate. The calculation is performed by using the building area method or the space-by-space method. Section 3 is the interior lighting fixture schedule, which shows actual wattage of the proposed lighting design. This value should be equal to or less than the allowed budgeted wattage. The fixture schedule should be confirmed both during plan review and the field inspection. Section 4 is the requirements checklist, which has all of the potential mandatory requirements for lighting wattage, controls, switching and wiring, and voltage drop. Each item has a checkbox, which should be checked, indicating that the item is present or marked not applicable for the project. The very end of Section 4 denotes whether the interior lighting passes or fails and indicates the percentage difference between design and code. Section 5 is the compliance statement, which reminds the applicant that the proposed lighting design is correctly represented and is consistent with the building plans, specifications, and other calculations submitted with this permit application. This statement should be signed and dated by an appropriate member of the design and construction team. Section 6 is the post-construction compliance statement, which states that construction documents with record drawings and operating and maintenance manuals will be provided to the owner. This should be signed by either the lighting designer or the contractor. Next, let's take a look at some examples from the Interior Lighting Compliance Certificate. First, verify that the design passes. Yes, we are 15% better than code for interior lighting. Next, confirm that the usages and square footages used to develop the budgeted wattage align with the plans. Now we can verify that the lighting schedules match what is drawn. At field inspection, confirm that the correct fixtures are installed as per the plans. There are several mandatory requirements regarding controls, such as Item 3 in interior lighting. Independent manual or occupancy sensing controls are required for each space, or a remote switch with indicator is allowed for safety or security. Or Item 5, automatic shutoff control for lighting is required in buildings larger than 5,000 square feet by time of day device, occupant sensor, or other automatic control. The next compliance certificate is exterior lighting. Section 2 shows the exterior lighting area surface power calculations for the total allowed wattage. Section 3 shows the exterior lighting fixture schedule and proposed wattage for the project. Section 4 is the requirements checklist, which has all of the potential mandatory requirements for lighting wattage, controls, switching and wiring, and exterior lighting efficacy. Each item has a checkbox which should be checked, indicating that the item is present or marked not applicable for the project. The very end of Section 4 denotes whether the exterior lighting passes or fails. Section 5 is the compliance statement, which states the proposed exterior lighting design represented in this document is consistent with the building plans, specifications, and other calculations submitted with this permit application. This statement should be signed and dated by an appropriate member of the design and construction team. The final compliance certificate is mechanical. Section 2 is general information and has the building location and climate zone. Section 3 is the mechanical system list. This should include all HVAC systems and water heaters on the project. The list should be confirmed both during plan review and the field inspection. Section 4 is the requirements checklist, which has all of the potential mandatory requirements for each specific HVAC system, each specific water heater, and a list of general requirements. Each item has a checkbox, which should be checked indicating that the item is present or marked not applicable for the project. Section 5 is the compliance statement, which states the proposed mechanical design represented in this document is consistent with the building plans, specifications, and other calculations submitted with this permit application. This statement should be signed and dated by an appropriate member of the design and construction team. Section 6 is the post-construction compliance statement, which states that HVAC record drawings of the actual installation and performance data for each equipment will be provided to the owner within 90 days after system acceptance, that HVAC O&M documents for all mechanical equipment and system will be provided to the owner within 90 days after system acceptance, and that a written HVAC balancing report will be provided to the owner. This should be signed by the principal mechanical designer. Now let's look at some examples from the mechanical compliance certificate. Please note that the certificate does not denote whether or not the design passes or fails, as the mechanical section is completely prescriptive. The first item to check is whether or not the HVAC systems and water heaters listed on the compliance certificate match what is on the plans. Yes, they do. Later confirm in the field that what is installed matches what is on the plans. Based on the type of equipment listed, CommCheck will display the minimum equipment efficiency. There are multiple mandatory requirements that must be verified as well, such as Requirement 12, duct sealing. Verify that pressure-sensitive tape used as the primary sealant is certified to comply with UL 181A or UL 181B, and verify sealing of longitudinal and transverse seams for ducts in unconditioned spaces. Now you have a basic understanding of how to use the CommCheck compliance certificates as a code enforcement tool. For additional tools and resources on the CommCheck software and current energy codes, please go to www.energycodes.gov.